Hi, I'm a spooky goose, and my experience with ghost hunting shows started sometime back in the first few seasons of Ghost Adventures. Back in this time frame, they were using a few electronic devices to aid in their ghost hunting, but more and more have been added as time goes on. In the current sphere of YouTube ghost hunters, it's rare to see a popular show not bring along at least 2 or 3 devices and applications to use on site. Sometimes it gets a little comical, with several devices in the same room going off at once, over and over, interrupting the hosts while they try to carry out pieces to camera. If it's not a REM pod screeching like a banshee, it's one of their 3 phone apps chiming up so the hosts can play word association games. While I don't believe that the triggering of any of these devices is proof of anything paranormal, I'm more open to standalone electronic devices that you can take apart, examine the components inside, and understand how they are working. Take the REM pod as an example. Kenny Biddle has a great article dismantling it and going through its components. In brief, it's based on an instrument called a junior theremin. This is a musical instrument played by a person waving their hands near 2 antennae, which changes the pitch and volume of the note being played. How does that go off during a ghost hunt if nobody's waving their hands around it? It's likely to be electrical interference of some kind. Walkie-talkies are known to be able to set off a REM pod from quite a large distance. Could it be a ghost setting it off? I don't find it likely, but at least with a REM pod there is a physical interaction taking place. REM pods are small, uncomplicated bits of hardware which are easily understood when taken apart, unlike a certain device we all carry with us every day. This video will explore how simple it is to make a phone app that claims to speak to ghosts, and is split into these major segments: how to trigger a word, how to choose a word, and how to make the experience feel more authentic. Let's start off by looking at triggers. These are things that we can use to start the process of a word being spoken. Timers let us trigger words due to the passage of time alone. When the timer hits 0, we have the app speak the selected word. Then we reset the timer, including some random variation in length to make it more realistic. The programming APIs for Android and Apple devices include built-in ways of running timers and executing code when a timer ends. They are the simplest of the trigger types, and to build a basic word bank app, this is the only trigger you would require. An accelerometer allows how fast a phone is accelerating or decelerating to be measured. A use case for this would be to detect when someone picks up their phone or when they start walking. This sensor can be used to trigger contextual words like move or stop. Being able to detect when someone picks up a phone using this sensor is also useful for making it feel like a spirit is reacting to the user. If a phone sat silent on a table for 20 minutes and then only speaks the moment the phone is picked up, that can't be a coincidence, right? This sensor does something with magnetism. Its proper use is for displaying compasses, but as this sensor mentions the word magnet, it's extremely valuable to a paranormal app developer. Paranormal investigators have believed that ghosts influence electromagnetic fields for decades, so it's something that they're guaranteed to trust. An app can use this reading to trigger a word when significant changes to its value are detected. Now that we know some of the ways that we can trigger words to be spoken, let's look at ways of picking a specific word. There are a number of ways of storing our words, but an array is the easiest. In simple terms, an array is like a book. Each item in the array is like a page, and they're all numbered. If we have 100 pages in a book, all we need to do to pick a page is have some kind of way of getting a random number. We all know about dice, right? they're random enough for our purpose. A six-sided die would allow us to pick a random page from the book, but only has the range 1 to 6, so those are the only pages we would be able to pick from. Dice can get big, though. Here's a 100-sided die on Amazon. With this die, we can pick any page from our book, so we roll it, we get 43, and we turn to that page. Oh, it's dead. What a surprise. Dice are clunky, though, and they're hard to fit inside a phone, so how would we generate that page number? Every mobile application is written using a programming language, and every modern programming language comes with the ability to generate a random number. It's such a basic task that it's usually part of the language. I won't go into the actual code here as it's very dull, but this is what that function typically looks like. So, if we wanted to replicate our 100-sided die, we would say, "Give me a random number between 1 and 100. Then we would use that randomly generated number between 1 and 100 to pick a page from the book, and therefore a word. And that's everything we need to do. We generate a number, we pick a word, and that word gets output to the user in some way, whether that's text, audio, or both. Couldn't we use readings from the sensors to influence the word selection? We could, but there would be little point. There is a principle in software design called KISS. It stands for Keep It Simple, Stupid. This principle emphasizes the need to keep software free of unnecessary complexity. The more complex a program is, the harder it is to write and maintain. Unless there is a tangible benefit to doing things in a more complex way, it should be avoided. If we link word selection to sensor readings, it would have no benefit. Even if we were to accept that ghosts can influence these readings, they have no way of knowing what values would trigger a specific word. While some may think that a ghost could read the words from inside the phone's memory, this is ludicrous. If a ghost were able to peek into the phone's memory, this is what it would see. This is binary, which is the way that computers store data. Everything in memory is a collection of ones and zeros. This isn't just text either. This is images, sounds, and even the code that runs an application. My old dusty phone has 8 gigabytes of total RAM. This is volatile, fast access memory that data must be loaded into to be accessed by an application. 5.6 gigabytes of this is usually being used by my loaded apps. This is over 44 billion ones or zeros. 1 billion is an unfathomably large number. It is unreasonable to assume that a ghost can read through and make sense of this much information that only makes sense to computers. If a ghost can't read the values from inside the phone, then it's up to the programmer to decide on what sensor values correlate to each word. But how would the programmer know what values to use? There's no way that they could. Assigning sensor values to words would be arbitrary. As ghosts can't read binary data, and programmers can't understand the meaning of sensor value changes, then linking word selection to these values would be needless complexity. Using a random number is therefore as complex a solution as we require. Now that we know how to select a word and how to trigger it, we need to get a little sneaky. We don't want the user to be able to identify patterns of behavior or to be able to trigger a word consistently using an action. For example, if the user is able to shake the phone and the accelerometer activity consistently triggers a word, this is too blatant. While we want to trigger contextual words to make the experience a little more tailored, we don't want it to be consistent and repeatable. Ghosts are notoriously unpredictable, and our app should match this expected behavior. How might we go about achieving this? My first thought would be to implement the idea of a profile. This would hold simple information about how aggressive a particular session will be. Each profile would control things like how often a random word can be spoken, how sensitive the sensor-based triggers are, how many words can be spoken, whether we should favor words that align with those spoke earlier, and so on. Imagine these two profiles. Dormant. This profile would keep activity to a bare minimum. It would have a chance of triggering a word every 60 to 120 minutes, and any other sensor triggering would be disabled. This profile would provide a, "oh, sometimes it doesn't find anything at all" level of realism. The extreme opposite profile would be chaotic. In this profile mode, the app would randomly trigger a word every few minutes, as well as being highly sensitive to EMF activity and motion. It could also trigger clusters of words close together for added impact. This profile would be a very rare one to select, with dormant or a profile in between being a much more likely pick. Each profile would also have the idea of a lockout period for each trigger. The more aggressive the profile, the lower the lockout time. Lockouts would be used to prevent the same sensor event from triggering in rapid succession. We don't want users to be able to predict the next time a trigger would happen, so we would also add an element of randomization to the lockouts. For example, on a medium profile, we might allow the phone picked up trigger to happen after an initial lockout of 30 minutes. Then once it triggers, set it to only be able to happen again in 8 hours. With these simple concepts, we can create an app that behaves in a way that people cannot immediately explain. This may initially appear to go against the KISS principle, but this area is a much more worthwhile investment of our time and effort. Preventing our app from behaving consistently is very important. It allows a kind of God of the gaps situation to occur. We don't know how this is working, therefore ghosts. And those are the simple concepts required to understand how to develop a phone app that talks to ghosts. Some triggers, a random number, and a little trickery. In fact, here's an app I made in an afternoon. I have minimal practical experience creating phone apps, but within a few hours, I had random word generation on a timer, as well as a trigger, based on the phone being picked up after laying flat on a table for 10 seconds. Within a few more hours, I could implement the profile concept, throw in a trigger for high EMF readings, and throw it up on the Play Store. Thanks for watching. I hope this video has given some insight into the way that this kind of app can be programmed and why any investigation that uses this kind of app should be taken with a pinch of salt.